Okay, so today we're starting our first lesson after your test, and we did the bisectors of triangles. So here we go. So the word bisector, as we know, means we divide evenly. So keep that in mind. So that's just making him and him equal. And that's specifically what we're talking about. We're talking about the sides of a triangle. All right, so here's the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So what does that mean? It means that it is perpendicular and equal. So that's saying that these two would be, and that since it goes through that center here, these two would also be equal. The converse to that, this again, if the point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So it's just basically telling you the same thing, frontwards and backwards. All right, so these should be pretty easy. So based on that information, we have perpendicular bisector here. So that means these two are equal, and that means these two are equal, which means that BC is going to equal 8.5 because of that perpendicular bisector. B, finding x. Why? Since we have this perpendicular bisector, that also means that these two would be the same. So that would equal 6 because of that perpendicular bisector. Here, same thing. These two would be the same, so we would just write 3x plus 1 is equal to 5x minus 3 and solve. Since x equals 2, but that's not what they're asking. They're asking for PQ. So we substitute that back in. And there it is. Oops. You see that? All right, next page. Point of concurrency. So your point of concurrency has to do with your intersection. And the concurrent lines of 3 or more lines that intersect. Okay, circumcenter theorem. So the perpendicular bisectors, so you've got your perpendicular bisectors of a triangle intersect at a point called the circumcenter. That it is equidistant from the vertices of the triangle. So anytime, this is very specific, so the vertices of your triangle to that circumcenter are all equidistant. So A to D is equal to B to D, which is equal to C to D. And again, circumscribed with a triangle inside. All right, so let's talk about where your center is. This is all about my center. Here, the center, when you have an acute triangle, your center is on the inside of the triangle. So you can see it. Here's the center. It's inside of your triangle. If you have an obtuse triangle, your center is going to be outside. Okay. And again, if we go back, all of these, that circumcenter theorem is saying that from these endpoints to the center are all going to be congruent. So again, A, D, C, D, and B, D are going to be congruent. Same thing here. Here's my center. Here's the vertices. All of these distances are the same. So this is going to be the same as this, same as that. So EX, DX, and FX. If you have a right triangle, then your center is on the triangle. So you can see it's right on it. And again, same thing's true. From here, here, and here to that center, these are all going to be congruent. So the question here, what kind of triangle is this? This is obtuse. So where is my center going to be? My circumcenter. Let's try to make a circle around this guy. So my circumcenter, since it's obtuse, is not going to be in the garden. This down here, we're trying to see what is congruent to based on perpendicular bisectors. So we're only looking at the bisectors, thinking about that. So if I looked MY here, so if I continue this side, I would know that YE is the same because of this perpendicular bisector. For K to P, so that's this guy, to the center, right? That means there's 3 of them because we have them all touching and they're all going to that circumcenter. So these would all be equal. So that would be EP and MP. M to N is going to be congruent to N to, what is that, R? What is that? Is it a K? NK. And that is it.